Hello everyone. In this video, I'll be presenting on AWS Elastic Kubernetes services. In this session, we will explore its key features, advantages, and how it streamlines the process of running Kubernetes on AWS. So, next, let's move on to the agenda. In this video, I'll be covering what and why, what are the features, deployment service, and its architectures, how EKS will work and its use cases, advantages and disadvantages, and also I'll explain challenges and consideration of EKS and also show the practical session of the Elastic Kubernetes services. So, what is AWS Elastic Kubernetes services? So, it's a managed Kubernetes platform provided by Amazon Web Services. It allow you to run, scale, and manage containerized applications using Kubernetes without the need to set up or maintain the Kubernetes control panel. So EKS automatically handles key infrastructures tasks such as scaling, updating, and ensuring high availability of the Kubernetes control panel. And it also integrates seamlessly with other services like IAM, VPCs, and CloudWatch, enabling secure, scalable, and monitoring deployment users can run application on EC2 instances. AWS Fabric or hybrid setups, EKS simplify Kubernetes management, making it ideal for hosting microservices, machine learning workloads, and scalable web applications. And it's a managed it's completely a containerized applications. So why Elastic Kubernetes services? So it's preferred choice for managing Kubernetes because it eliminates the complexities of setting up and maintaining Kubernetes control panels and ensuring a high available and a secure environment. And it also integrates with the AWS services like IAM for authentication, VPC for networking, and a CloudWatch for monitoring, provide a robust ecosystem for your application. And it also supports hybrid and on-premises Kubernetes workload, offering flexibility for various deployment needs. Additional, it scales effortless to handle high demand workloads and provide cost efficiency by letting you pay only for the resource you use, with AWS managing the operational aspects, and EKS allow you to focus on building and deploying containerized application. So the next is key features of AWS EKS. So in this first one we have a managed Kubernetes control plane. So it's automatically provisions and manage the Kubernetes control panel, which includes the Kubernetes API servers, etcd, and other critical components. These control plane components are distributed across multiple availability zones to ensure high availability, and AWS handle tasks such as patching, scaling, and securing the control plane, freeing your operational overhead. These allow you to focus on your applications without worrying about managing the Kubernetes infrastructure. Fagret support, it's enable you to run Kubernetes pods without provisioning or managing underlying EC2 instances. These serverless approach simplify Kubernetes operations by abstracting infrastructure management. It ensures that the resources are allocated efficiently based on your application needs, reducing cost and improving scalability. Fagret is particularly useful for small workloads, batch jobs, or scenario where managing work nodes is unnecessary. Multi-region clusters. With EKS, you can deploy Kubernetes cluster across multiple AWS region, ensuring enhanced resilience and performance. Multi-region clusters are essential for disaster recovery and a business continuity, as they allow applications to remain operational even if an entire region faces an outage problem. Additionally, having cluster in multiple regions reduce latencies for global distributed user and improve overall application responsive. Integration with service mesh. AWS EK is integrated seamlessly with service mesh tools like Isto and AWS App Mesh, providing advanced capabilities for managing traffic between microservices. So these tools enable features such as traffic routing, observability, security, and a resilience. So these are the key features of the AWS EKS. So the next thing we have is a deployment. So, a deployment in Kubernetes is a declarative way to manage the state of your application pods. It provides a robust automation for scaling, updating, and self healing. And the deployment have some key features, so let's understand those things. So it has a declarative updates. It defines the desired state in YAML file. In YAML file it define all the things. Kubernetes ensure your application matches it. So and it's a rolling updates prod gradually to prevent downtime, to avoid such things. So rollback, revert to previous version if something goes wrong. Scaling, easily scale pod up or down based on the load. Self healing, automatically heals the pods. So these are the deployment. So the next thing we have is a services. A service in Kubernetes is an abstraction that define how to expose and access a set of pods, providing to stable way to connect them to regardless of their changing the IP addresses. In this, we have some key features. Stable networking. It provide a consistent IPs or a DNS for accessing our pods. Selector mechanism, routers traffic to pods matching the specific labels. Load balancing, it distribute the traffic amount pods for high availability. It distribute the available traffic for different services. So the next we have is it's a Kubernetes package manage. They simplify deploying, managing, and upgrading application using pre-configured templates called charts. And here we have a key features, that is simplified deployment, and it can quickly deploy applications like Nginx, like that using charts. Customization, parameterized configuration to adapt to different environment. Dependency management, it automatically resolve and install applications dependencies, and it's also have a version control. Track version of your application deployment for upgrade and rollbacks. So the next thing we have is the AWS architectures, EKS architecture. So Elastic Kubernetes services provide a robust and a scalable architecture that simplify deploying and managing Kubernetes service clusters. Below are the components, core components of the AWS EKS architecture and their functionalities. The first thing we have is a Kubernetes control plane managed by AWS. So the control plane is a heart of Kubernetes cluster, responsible for managing the cluster state, scheduling workloads, and handle API requests in AWS EKS. The control plane is fully managed by AWS, providing the following benefits like high availability across multiple availability zones, automatic patching, upgrading, and scaling, secure endpoint with integrated AWS IAM for access control. You can only interact with the Kubernetes API server through kubectl or other tools, while AWS handle the underlying infrastructure. And we have as a work nodes hosted on EC2 or a Fabric. So EC2 instance work nodes are typically EC2 instances running the Kubernetes kubectl agent. These nodes run the workloads that pods and communicate with the control plane. So AWS Fabric for serverless operation, AWS Fabric can host pods without any infrastructure management. Fagre dynamically provision resource based on the application requirement. Networking. It's integrated with the virtual private cloud for private communication. AWS EKS cluster integrated seamlessly with Amazon VPC, enabling secure and private communication between worker nodes and control plane. And it adds some key features like private subnode, security groups, and elastic load balancers. storage, and it supports EBS, S3, and a EFS for persistent storage. So it supports various storage like block storage for individual pods for application, object storage for storing logs, backups, or other unstructured data, and EFS shared file storage for multiple pods requiring stemless access the some data, same data. IAM integration. So, identity and access management provides secure and granular access control for both user and application within the cluster. You can use user authentication, pod access control, and service accounts. So, and the architecture flow comes like user or tools interact with the Kubernetes API servers in the managed control plane. The control plane schedules workloads and manage the cluster states. Workloads are executed on the worker node, that is EC2 instance or a fabric. Networking is handled securely with the VPC with operational integrated of the load balancer for external traffic. Persistent storage and other AWS services are used as needed with access managed by IAM. These architecture ensure the AWS EKS provides a high available, secure, and a scalable environment for running Kubernetes workflow. So let's understand how AWS EKS will work. So first, it will create a cluster creation. You start by creating an EKS cluster using the AWS Management Console or the AWS command line interface. AWS set up the Kubernetes control plane and it's the brain of the cluster for you, making it ready for use. Node group setup. After creating the cluster, you add worker nodes to run your applications. You can choose to use EC2 instances or AWS Fabric. AWS Fabric is a virtual machine which automatically handles the resource for you without needing to manage the servers. Application deployment. To deploy your application, you write a configuration file in a YAML format that tells Kubernetes how to run your containerizer, like called pods. You use the kubectl tool to apply these files to cluster, and Kubernetes makes sure your applications run as expected. Monitoring and scaling. AWS CloudWatch help you to monitor how your cluster is doing, like tracking the CPU usages, memory. If your application needs more resources, Kubernetes can automatically scale up your applications or down. Additionally, you can set up automated scaling for worker nodes if more capacity is needed. In short, AWS EKS make it easier to run Kubernetes on AWS by managing the complex parts of you, allow you to focus on deploying and scaling your applications. So the next thing we have is a use case of AWS EKS. So it offers flexibility for various applications. The first we have a web applications. So it's automatically scale web application based on the demands. And EKS provides strong security features like IAM rules, VPC integration, and encrypted communication. Microservices. It distributed application management, easily manage, deploy, and scale microservices. Efficient resource allocation for Kubernetes helps in managing the complexities of microservices by optimizing the resource. Batch processing. High performance executions for run large compute intensive tasks such as video render, data processing, and scientific computing. Cost effective pay only for the compute resources used during execution with auto scaling to manage the workload. Machine learning, model training use cases. AWS uses EKS to run train machine learning model at scale with access to large database. Model deployment easily deploy the manage machine learning models in a production for the real time interfaces. So let's understand what are the advantages of EKS. It's completely a fully managed Kubernetes platform. It's AWS take care of Kubernetes control plane, ensuring high availability, security, and scalability. No need to manage infrastructure or worry about the maintenance. Simplify containerized. orchestration. Easily deploy and manage containerized application using Kubernetes, automated scaling, load balancing, monitoring, and simplify the orchestration process. Optimized for AWS ecosystem. It seamlessly integrated with other AWS services like IAM, VPC, CloudWatch, and RDS, and it takes the advantages of AWS features like Fabric for serverless compute and EFS for persistent storage. Enhance operational efficiency. Kubernetes provides advanced features for self-healing, auto-scaling, and a easy deployment updates, helps team focus on building applications while AWS handle the infrastructure. So let's understand the disadvantage. What are the cons of the EKS? So offers many disadvantages. The first thing is cost. EKS can expensive, especially when running large scale clusters. You can incur costs for the control plane and a worker nodes, as well for the other AWS services like storage, networking, etc. Complexity. Also, Kubernetes simplify the container orchestration. Managing EKS clusters still requires knowledge of both Kubernetes and AWS services. These can be challenged for team without expertise in both areas. Scaling overhead. While EKS supports auto scaling, configure and managing it can be complex, especially when scaling work nodes across multiple availability zones. Limited customization. EKS uses a managed Kubernetes control plane with restrict certain customization. If you need to specify changes or a deep control over the Kubernetes control plane, it might not be flexible enough. Integration overhead. EKS integrates with the various AWS services but integrates others non AWS services may require additional efforts or tools which could increase complexity. Cluster limitations. There are a limitations to how many nodes, pods, and cluster you can have in an EKS environment. Managing and maintaining large number of cluster can become a more complex. So next, understand the challenges and consideration. While AWS EKS provide a robust and a powerful solution for managing Kubernetes workloads, there are several challenges and consideration to aware of when adopting the scaling EKS in a production. So cost management for large clusters. So while EKS itself has a managed control plane, cost the associate infrastructure can lead to significant cost for large cluster. The number of work nodes, persistent storage, and data transfer can quickly accumulate. Node cost. So if you are running EC2 instances for your work nodes, optimizing the type and number of instances become crucial to avoid unnecessary cost. Over provisioning nodes can lead to wasted resources, while under provisioning may result in performance degradation. So Fabric cost. If using AWS Fabric to manage pod without EC2 instances, the pricing model is based on the requested CPUs and memory resources for each pod. Managing these resources efficiently is necessary to avoid high pre-pod cost, especially for workloads with a fluctuating resource demands. Data transfer cost, network cost between services within the EKS cluster as well as between the AWS region or to form on-premises infrastructure can add up quickly, especially in a multi-cluster or a hybrid environment. These are the challenges we face in the cost management. So what are the consideration for this? Use AWS cost exposures on a third-party cost management tools to track and optimize usages. Implement auto scaling to dynamic adjust resource based on the demand and avoid a over provisioning. So the next learning curve for Kubernetes newcomers. So complexity of Kubernetes itself has a step uh, learning curve, especially for teams that are new container orchestration. Understanding concepts like pod, deployment, services, namespace, and a persistent storage can be overwhelming for beginners. EKS specific features. While EKS simplifies certain Kubernetes tasks, like there are still AWS specific tools and integration. mm, CloudWatch that required additional learning. For this, we need additional learning. So, Kubernetes configuration management. Managing Kubernetes manifest, charts, and YAML files can be challenging, especially in a large scale environment where version control and configuration drift configuration become important for concern. So consideration, provide adequate training to your team for considering hiring Kubernetes expert for initial setup and guidance, and also manage services tools like AWS CloudFormation and Terraform to simplify the cluster provisioning and management. Use Kubernetes tools like kubectl and ekctl to manage the complexity of the Kubernetes resources. So, monitoring and logging at scale. Monitoring multiple clusters in a large environment, managing and monitoring multiple EKS clusters can become difficult. Collecting metrics, setup alerts, and weaving logs in a centralized manner across all clusters require additional tooling. Logging complexity, it integrated with the CloudWatch for logging, but managing logs from many different pods, containers, and services at scale requires thoughtful organization and efficient for log aggregation. Resource metrics. Monitoring key performance metrics like CPU, memories, and network usage at scale can lead to high volume data generation, which can be hard to manage without proper instrumentation and automated analysis. Alerting and incident management, setting up alerts for failure, scaling event, and resource executions across distributed microservices may require fine tuning of AWS CloudWatch alarms or third party monitoring tools like Datadog or a Nutanix. Consideration, set up a centralized logging system using Amazon CloudWatch logs or a third party tools like ELK or FluentNet. Implement proper monitoring dashboard with AWS CloudWatch metrics or a Prometheus and establish alerting rules to detect issue proactively, and also leverage AWS X-ray for distributed tracing and pinpointing performance bottlenecks with microservices. So these are the challenges and consideration of the AWS EKS, and this is the theoretical part of the AWS EKS. So let's go to the AWS account. I'll show the practical session of the AWS EKS. So before moving to the AWS account for creating the AWS EKS, so we need to install something called EKS install and a kubectl install in a AWS command line. So for that year, I'm using VS Code for and also the WSL to configure those things. And later we'll move to the AWS account and can we can create AWS EKS. So let's install those things first. So I have taken the WSL access. Uh, let's go and install EKSTL for the command line interface. So in this you can search for EKSTL installation and go for the first link. So here scroll down. So here we use for the Unix, and here you can see for Windows also. So copy this one and paste it here, and it will install. See, it will unzip our things and it can move to temp pkctl to local bin folder. So click on enter. So let's wait few minutes. See, it's showing the ekctl linux star has been installed and it's showing for OK, and here it's asking for password for the WCL. So it has been installed. So EKSTL has been installed. Now we need to install a kubectl. So kubectl install. So go to the install kubectl. So here kubectl on Linux. So scroll down. So here we need to copy this. First install kubectl binary with a clear on Linux. So copy this. So the next step what we need to do is, so second, validate the binary. So down we need to validate whether the binary will download it or not. So let's validate. So it has been, so yes, it has been installed. So the next step what we need to do is, so validate the kubectl binary against the checksum file. If it is validate, it will show that kubectl is okay. Otherwise, it will show that kubectl is fail. So let's validate those things whether it is installed or not. So it's showing kubectl is okay. That means the kubectl has been installed. So now we need to so before we have installed the binary things and the binary kubectl is okay. Now we need to install the kubectl. So copy this. So yes. So to ensure the version you installed is up to date, so copy this one, paste. So it will showing the client version and a customized version. The kubectl has been installed. The two things we need to install, that is EKSTL and a kubectl were installed in a AWS command line interface. So let's move to the AWS account for Elastic Kubernetes services. So go to the, in the search bar you can type EKS Elastic Kubernetes services. Go that. So this is the UI of the Kubernetes. So here we can see. So here they have given some documentation. And here you can deploy this in a two-way. You can create cluster through this interface, or you can use the documentation, um, and also you can use this in a AWS command line interface. When you go to the create cluster, so it will ask for the name, Kubernetes version, cluster, IAM role, node, IAM, VPC, subnets, everything it will ask, and you need to manually give those things. So when you go to the documentation, enter user guide. Here go to the quick start. So here they have given us how to deploy the clusters and everything. So we'll follow these steps. So before, see, they have told us prerequisite, set up the AWS command line configuration for credential. We have not set up the credential yet. I'll show you how to set up the credential. And we have installed the EKCTL, and also we have installed the kubectl. So here, let's clear the screen. So sudo AWS configure. Sorry, I have mistake. Sudo AWS. So when you give AWS configure, it will ask for the access key. give the access key and a secret key for this. And we need to provide a secret key. So it will asking me for a default region is EU North 1. So I'm using the Stockholm. The region is in the EU North 1. The default, yes, I need the default region for that only. So and the default output format is none. Give and enter. So that means now we have configure this setup AWS command line and configure credential. We have set the confident credential. So the next thing what we need to do is we need to configure the cluster. So let's create one file called cluster configure.yaml. So here they have provided us the YAML format file script they have been provided. Just copy and paste the script. So here the given ekctl script is a configuration file for setuping an Amazon Elastic Kubernetes server cluster, and the API version ekctl.io v1 alpha 5. So specify the API version of ekctl. This version defines the scheme for the configuration file, and v1 alpha 5 indicates it's an early version with features and operations specified to the realize release. So kind, here we have using kind called cluster configuration. It specifies the type of resource to configure. In this case it's for creating a Kubernetes cluster. Metadata, it provide a identify information for the cluster, and here we have given a name called web quick start. So set up a name for the cluster to web request. This is how the cluster will identify in a AWS. So region. So here we need to give the region. Here what they have mentioned the region code. So here we need to specify our region. So specify AWS region where the cluster will be deployed, and we need to replace with the valid AWS region code, such as you can whatever the region you want, you set that one. Here I am using North 1, you North 1. And auto mode configuration. This section is for enabling automation features and ekctl, and the enable is true. Activates automation mode where enable. Default configuration for networking node groups and IAM rule may be applied automatically, and it specifies the setup process by reducing the need to specify very detailed. Ideal for quick start setup or a user who wants a functional cluster without extensive customization. So what is the purpose of this scripts? It's create an EKS cluster. That script define a basic configuration of deploying an EKS cluster using and simplify the deployment process by enabling auto mode configuration. The script handle many details automatically, making it easier for user who are new to Kubernetes or a EKS, and it's suitable for quick start testing and a proof of concepts. So let's save and come out from this. So let's see what is the next command they have given. Now we are ready to create a cluster. So create the Amazon EKS cluster. So copy this command, paste it. What's the command say? EKSCTL create cluster -f cluster configure YAML. So these command ekctl cluster -f cluster config YAML creates an Amazon EKS cluster based on the setting in a file cluster config YAML. What it does, it reads the configuration file, look at the setting you defined like cluster name, region, and any other automation features. Setup resource automatically creates all the necessary AWS resources, include Kubernetes control plane, work nodes, networking, everything, and it will connect it to your cluster, updates your local configuration so you can interact with the cluster using kubectl. So click on this. So it will took some time. So let's wait for this. And also we can see the stack in a cloud formation also. So see, it will showing the web quick start cluster is in a creating process. So let's wait until the process will completed and in an active state, and the after the cluster have been completely deployed, that will show, that will appear here. So see, it's in a creating state. So the status is it show in the active state. So let's wait for few minutes until it will active. See, it will setting availability zone, and it's also checking for subnets, and it's using Kubernetes version 1.3, and the cluster web quick start in a UU North 1 region with. So all has been showing an endpoint access with use default public access and a private access in U not one. So it's took time. So let's wait another few minutes until it will get deployed. So see, in the cloud formation, the quick start cluster creation is completing. It has been showing. So let's see whether in the EKS it will active or not. So as it has been installed and it is in a active state. When you go enter to the quick start, so we can see the status and the version, supported period, and provider is a EKS, and you can also see the cluster health issues, upgraded insights, and node health issues, and we can see the overview of the EKS, and we have several things you can go through. As there any updated history we have, so you can go through all those things for this. So we are not getting, so wait. So as the EKS cluster web quick start is ready to start. So let's go to this and let's see now. As of now we have configuring the cluster thing. So now we need to create a ingress class. So why this ingress class? So creating a Kubernetes ingress class for EKS auto mode. The ingress class define how EKS auto mode handle ingress resources. This step configure the load balancing capacities of a EKS auto mode. When you create ingress resource for application, EKS auto mode use this ingress class to automatically provision and manage load balancer to integrate your Kubernetes applications with AWS load balancing services. So let's create this file. So in this we need to specify the YAML script of this. So what this script will tell. So the YAML configuration defines an ingress class resources in Kubernetes. It set up a default ingress class for handling network traffic through AWS application load balancer. API network.ksio v1. So these specify the API version of networking resources. Ingress class is a part of networking.k. It is IO API group. So the next we have is a kind ingress class. So here it represents a class of ingress controller. It tells Kubernetes how to handle traffic for ingress resources and metadata name ALB. Name this ingress class as application load balancer. These can be referenced in your ingress resources. Annotation ingress class dot kubernetes io is default class is true. So marks these ingress classes default. Any ingress resources without explicitly defined class will these use these ingress classes. And specification, here we have controller EKS. These specify these ingress classes managed by application load balancer. Ensure that the traffic routing is handled by application load balancer in Amazon AKS. What are the purpose of this script? These configurations set up Amazon application load balancer as the default ingress controller for your Kubernetes cluster. Any ingress resource created without specifying an ingress class will automatically use this application load balancer configuration. So we have created the we have created ingress class.yaml. Now we need to apply the ingress to the your cluster. We have created a cluster. Now we are applying the cluster ingress class to our cluster. So this command used to apply the configuration defined in the ingress class.yaml file. To our Kubernetes cluster. So it reads the file. Kubernetes read the ingress class.yaml file to understand the desired configuration. It creates or updates the ingress classes. If the ingress class does not already exist, Kubernetes creates it. If exists, Kubernetes update it with the new settings. Registers with the ingress class. The cluster recognize the ingress classes, in this case named application load balancer, as the default for handling ingress resources. So yeah, it's showing some error. So let's check what the error I am facing. Oh, nothing error is there. We need to specify a sudo in this command. So see, the ingress networking ALB is created. So let's check what is the next what is the thing we need to do. So next we need to deploy the 2048 game sample application. So in this section we you through step to deploy popular 240 game as sample application within the cluster that we have created. The application provided manifest include custom annotation of the application load balancer. So these annotation integrates with the direct HTTP incoming traffic and internet facing and route the appropriate. So let's create a Kubernetes a namespace called game 2048 with hyphen configuration flag. So let's run this command. So let's understand what the command means. So this command kubectl create namespace 2048 save config creates a namespace called game 2048 in your Kubernetes cluster and save the configuration file in the Kubernetes API servers for the later use or modification. So kubectl create namespace game. It creates a namespace called game 2048. A namespace is a way to organize and isolated resources like pod services etc in a Kubernetes cluster. Hyphen save config. It stores the initial configuration of the namespace as an annotation in the Kubernetes API servers. This makes it easier to track the original configuration, especially useful for tools like kubectl apply or kubectl different later. So let's check. So yes, the namespace 2048 is created. So before entering to the command, so please add sudo command before to the command. So next command we have is so deploy the things. Sample application. So when we deploying this application, we have command. What does this command do? kubectl apply the resource defined in the YAML file, and -n game -2048 specify the game namespace where the resources will be created. -f and the URL, it downloads the 2048 full YAML file directly from the URL. From this URL, it will download the file, and this file contains the configuration for deploying the 2048 application in the Kubernetes. So what is in that YAML file? The 2048 full.yaml file likely includes deployment. It defines the 2048 game applications, pods and containers, and services. Expose the application to the cluster by cluster IP, node port or a load balancer. Ingress configures routing to the application, potentially using the AWS load balancer controller. To add a sudo command. So see, it will create deployment services ingresses for us. So next command, see the next command. So run the following command to get the ingress resources for the game space. So when we give this command, it will give us one address. So what this command does, kubectl get ingress, list all the ingress resources manage https routing to your services -m game 2048. It limits the result of the game 2048 space. So this will give us a address. So copy this address, see, and its port is 80. So go to Chrome. So paste that address. So when you cube the kubectl sudo kubectl get pods -n game 2048. So this will show the running status of your application. So see, 2 minutes 26 seconds back we have created the things that will show the pods that we are running in the cluster. So when you copy this address in the Google, so you will see like this page. You will see when you copy this address bar, you will see the sample application of the 2048 game. So here they have mentioned how to play this game. So by using upper arrow keys, you can merge it to one. So we can play this game. So everyone know this game, but we have created a sample application for this. So see, this is the thing, how the application will, this is how the application will work. And AWS will provide a documentation for us. They only provided the steps to deploy the cluster of the sample application. So like this we can deploy the application of these things. So also we can see it will in a created state. No. So AWS EKS is a not a free of cost. So it will charge us for us. So what we need to do is, after creating this cluster, we need to delete this cluster. For delete the cluster and nodes also they have given some code. So let's copy this code and paste it here. So this command ekstl delete cluster. So this will delete the quick start cluster. So I'll show you. So see, it is in a creating state, right? So now it has been changed to the deleted in progress. So you can delete the application. So this is how the practical session of the AWS Elastic Kubernetes services will work. So I have explained every topic and I have covered everything in a practical session of the AWS EKS, and also have shown the practical session also. So that's all about AWS Elastic Kubernetes services. Thank you.